Hello, my lads, comrades. Welcome to the last study session of senior year. I hope you're having a good night tonight. We're going to get started with chapter 7. Sorry, wow, long night. Chapter 7 with Precal12, and we're going to get into the questions that are there. Again, as we go through these, if you have further questions on this, please feel free to message me, and we'll go from there. But we're going to hit on a couple of them. That's a couple of your questions there, and then we'll rock and roll. So let's do this without further ado. Let's get started right here. And in fact, what we're going to do is I'm going to pull up my calculator on this, and I'm going to pull up this one here. While that's pulling up, one thing that I do want to mention to you that's very important, make sure that you mention to me at some point how to do one of these systems of equations when you have it without doing a matrix, okay? So without a matrix, that's important. So we'll hit on that. So just make sure you touch base with me on that going forward, all right? All right, so I'm going to do this. I'm going to hit heavy on the matrix stuff today on the calculator, and that way, if you have questions or anything like that, we can go through it together on that, and then we'll rock and roll, okay? All right. Sorry, trying to get some coffee in me. All right, so one of the important things that I do want to hit on before I get to this is that let's say that after you do a systems of equations, whether it's through elimination, right? Remember eliminations where if I had like x plus y and x minus y equals 6 and 8, y's cancel, leaving me with 2x equals 14. That's called elimination. But if I had like x equals 6 minus y, and then I had another equation which was like 2x plus y equals 10, I could substitute 6 minus y in for that x that's there, okay? And that would be what we would be looking for when we simplify. So that would be called substitution, whereas the top would be called elimination, okay? So just know the difference between the two as we keep going forward, all right? All right, Tim. So do this. Take out your calculator real quick. We're going to go to this. Let me make sure. Where are you? Let's do this one. All right, let me see if I can pull this up. My fault. Where are you at? There you are. Okay, so I'm going to pull up my calculator here, and should look something like this. Okay, so if you're following me on your matrix, on the matrices there, we're going to plug in specific values. So let's plug in. So you could follow me down below. You see my key press history, but I'm going to go to second x the negative first, okay? So we're going to start there. Now, remember with the matrices, the important thing to kind of remember on this is, I'll push these down so I can see this. The important thing to note on this is that when I go to like number 1, we've got 3 systems of equations. So because of those systems of equations, what we're going to do is we're going to go to the edit button. What that does is that allows us to edit the type of matrices we have. So when I press enter there, you'll see that kind of going across. Now, since we have 3 systems of equations, you'll see it up above on 1. You'll have 3 systems, so we're going to have 3 different rows. So we're going to have, remember it goes 3 by 4. That means rows by columns, okay? So we're going to substitute in now. Now, what do you have as far as columns are concerned? This represents the x, the y, the z, and the solution. Okay, so x, y, z solution. So what we're going to do once I get there is I'm going to plug in. So like the first one would be 3, enter. Next one would be 2, enter. Next one, -5, enter. Okay, -10, enter. Good, add 2, enter. 4, enter. 1 enter, and 0 enter. Now, all of these have had them so far. Like this one would be 1 for the next one. When you do the -6 that's there, make sure you use the negative down yonder. Okay, just be careful on that. So -6. Next one's -4. And the last two is, or the last one's -3, okay? And so once I press enter there, we got our matrices filled out with each one in there. Now, if sometimes in cases like, well, we'll get to one, like we'll do number 3 or 4. Sometimes in those situations, you got to be careful because you've got to fill in the missing variable. So if you like don't have a z in one of the equations, you can't just fill in whatever. You have to put in a 0 for that value. So what we're going to do now is you're going to go to second quit. You're going to go back to this blank screen. Now, in order to simplify this matrices, you're going to go to second x to the negative first. And by the way, you can't do matrices for everything. You'll have a calculator and non-calculator part. So just a heads up on that, okay? So once you're going to, what you'll do next is go to RF, which is row reduced echelon form. And then you're going to go to second x to the negative first again. And then you're going to press enter on the names. Now, don't go to the edit because once you do, you'd be editing it. But just to put that in, you're just going to put that in there. Close that parenthesis. Press enter. To where now we have, and you'll see it here. Remember, this is the x column. So x is equal to 0.5, the solution column. Y is equal to -0.75. And z is equal to 2. So you'll just plug that in accordingly. And that's it. That's all you would have to do for that matrices there. And you'd be rocking and rolling. Now, another one that, man, we really need to hit on to make it a little bit more tricky. And by the way, number 2 might be a little bit tougher. You'll have, that one's actually going to be a 4 by 5 because you have an x, y, z, w, and solution with 4 different equations. So just be careful of that, okay? Now for the next one, number 3, we're going to go to that one. Again, we'll go to second x to the negative first. As I go to the edit, I noticed, and I'll press enter here, I noticed that there's only 2 equations, and this time we actually still have 3 variables with the solution. So we're going to put a 2 by 4. Now it's going to be a little bit more entertaining because you'll see why here in a second. So you're going to go 2, 4. We'll go to -2. And we'll do 0. Perfect. The next one will be 3, 5, 0, 1. So we'll go 3, 5, 0, and 1. All right. So what you have there is this matrices that's on number 3. You got 2 equations with 3 variables and a solution. So guess what we're going to do? We're going to go to second quit again. Go to second x to the negative first. You're going to go to math. Going to go to RF again, and then you're going to go to second x to the negative first again. Press enter. This looks very familiar, doesn't it? You're going to press enter there. Now watch this, okay? Now I'm going to write this down. You're not going to be able to see this quite yet, but I'll show you here in a second, okay? So I'm going to clear this, okay? Let's see. Come, they told me. 1052. So we're going to go 1052 right there. And then the next one will be 01, -3, -1. So 01, -3, -1. Now, I'm going to come back to that because we can do number 4 here in a second on that one. But I don't want you to see, I know you're looking at me right now, I think. Okay. Yeah, this is what I want. Okay. So this right here means the following. This is what this means. X plus no y, right? So x plus 5z equals 2 is what we just found there. Okay. The next one says y minus 3z equals -1. Now, as you notice here, each of these have z and x and y are by itself. So what we're going to do, there's no way we can really find a solution. So what we're going to do is we're going to isolate x and y in terms of z. So this first one will be as follows. X equals negative 5z plus 2. The next one is y equals positive 3z minus 1. So what we have now is our x and y equation in terms of z. And then what we can say is now z equals z. Now you might say that, Coach, that's really confusing. Well, and I get that because it's not really numbers. I get it. But because of the fact that we had only 2 equations with 3 variables, that allowed us or forced us to be able to have our x, y, and z, what we're trying to solve for, has to be in a common variable. So that's why we use common variable would be z in this situation. All right. Now, sometimes that's not always the case. Sometimes it kind of switch or flip-flops. But because of this, you'll see there's no solution for this that's an actual whole number. So we have to designate them with variables depending upon, really we need more information to determine that, okay? Awesome. Okay, so let's go to our final one, which is number 4. That's a good one right here. Let's go to this one. Sorry, we're going to go to this last matrices here. We'll hit on a couple more here, and we will be okay. Okay, so this last one, last matrices one, is number 4. Okay, so if you're following there, number 4 is kind of where we're at. Okay, let's go across. Okay, perfect. So we have 3 equations. So we're going to go boom, boom, right across. Press enter. Okay, so we're going to have 3 equations. But notice this, we only have 2 variables. We have x and y and a solution. So we're going to have a 3 by 3. Okay, so as we go to the first one, we'll go 1, 2, 0. The next one's 1, 1, 6. The next one's 3. Well, just get -2. And 8. Okay, so here's my 3 by 3. So we're going to go to second quit. Okay, then we're going to go to same thing, right? So second x to the negative first, go across to math. You're going to start memorizing this because we're trying to reduce this, right? Try to simplify this, which, by the way, while I'm doing this in college, you'll probably get a little bit more of this as you keep going. Like, you'll know how to do it by hand and different things like that for some of you going into those fields. So we're going to press enter. So let's look and see what this means, okay? In fact, let me do this. Let me go on this side because we're going to be done with the calculator here. Oh, actually, we might go one more. Actually, I might go one more. Okay, so this is what this is saying, okay? Ready? This one is literally saying 1, 0, 0, 0, 1, 0, 0, 0, 1. Now, on this may seem harmless, right? So this is x, this is y, this is the solution, right? But if you think about it, this is saying x equals 0. Okay, good, I got that one. X equals 0. The next one says y equals 0. Okay, that's perfect. But then look at this. This one doesn't have one on the x or y, so really that means 0 equals 1. Well, can 0 equal 1? The answer is no. They can't equal 1. So actually there will be no solution. Remember that in the circumstance where a no solution occurs, when there are 2 lines that are normally parallel, they will never intersect. There's no intersecting point. So that's why we have no solution. We call that inconsistent, right? Inconsistent. So that's when like you get something like this where 0 doesn't equal 1. It's not true. So we call that no solution or inconsistent. Sometimes you get one where it falls on top of itself. It's the same line. That's when it has like 2 equals 2. That is true. And so we'll say that that's infinite solutions. And that is consistent. Okay? So the only time it's inconsistent is when there's no solution. All right, when there's infinite solutions, you're fine. And then the traditional one where they intersect, right? That's the one you normally see where like x equals 2, y equals 3. where you have one intersecting point or even multiple intersecting points. We call that one solution, two, depending upon what you have, that is consistent. So we say this is consistent. And in this case, there's only one solution. So just giving you a heads up on that as you progress in some of these lesson parts here, okay? All right, so this next one, number 5, is another one that's using the calculator. I'm trying to hit a lot of the calculator ones, and then I'll hit on a couple of the other problems, a couple of the word problems we'll hit in class. And that might be a good thing to do in class together. That way we can talk through any questions you may have. All right, let me see. We got a couple viewers on there. Thanks for showing up, y'all. I really appreciate it. If you have other questions, I'm going through these right now. But if you have other questions, let me know, and we can deviate from that. Okay. Now, number 5 is one where we're gonna solve this equation or solve this solution set by systems of equations by the calculator. So what in both of these we want to isolate y. So in like the first one, I'm going to say y squared equals negative x squared plus 25. Okay, do you see that? Because I subtracted that x squared over. Now this next one, I'm going to kind of have to do a couple things. So I'll say negative y equals negative x plus 1. I'll change the sign here, which changes the sign here and here. So really this is y equals x minus 1. So really there's 2, right? But the problem is that this right here is not by itself, so I have to square root. When I square root a squared, what happens to the other side? Well, the other side, and in fact right now I want you in your house to scream out right now, just like Dora the Explorer. What would you do next? What would happen right here? It's exactly right. We have a plus or minus when we square root a squared. And so we really have 3 different equations that we have here. Now this is the weird part. Most people get this. Most people will forget the plus or minus. Just remember though, square root is squared. We have plus or minus there. So we really have 3 equations we plug in. One positive, one negative, and one x minus 1. Okay, so the big key is determining what are the solution sets or where does it intersect. So let's do this. Let's go to, oh yes, perfect. Okay. I'm going to clear my calculator and I'm going to go towards this one. What is up? Good to see y'all. Okay, start screen share there. Perfect. Okay. All right, so we're going to go to y equals, okay? And I kind of already did one similar to this, but we're going to kind of change these up just so we got. So with the y one, we have one that is the square root of negative x squared plus 25. Okay, that's the first one. The second one, the only difference is that now we have a negative of that, so it's the same thing. Negative square root of negative x squared plus 25. Okay. All right, perfect. Yes, and I can do the last one too. I think that's number 16. I think that's number 16 that I can do. I will for sure do that one. Okay. Is that the one with the calculator? Are you using a calculator on that? It may not be. It shouldn't be arrow. I'm sorry. I think that's one with no calculator on it. So I think I'll do it without a calculator. It says use a matrices, but I'm going to do it the other way. I'll do it the long way there. We'll go from there. So let's graph this thing. So here we go. We got this one cutting across. Okay. So now the key is to determine where these two intersect. We have a pretty good idea. You could probably kind of see it, but we can't assume anything. We want specifics. So to kind of calculate this, we're going to go to second trace, which is the calc button. And you're going to go to intersect, which is number 5. So you're going to go down and press enter. Now, if you have one that has a color on it, it makes it a little bit easier. If not, you just got to understand that there's 3 equations, one on top, one on bottom, and one obviously the line going across. So we're going to try to find the intersection of this, where the line intersects with this curve, the blue one. So I'm going to press enter because it says first curve, question mark. And as long as I'm on that first curve, that's all I care about. So I'm going to press enter. Now the next curve, it says is the red one. I don't want that one. So to kind of go between the two, you see kind of the arrows right over here. If I push down, it kind of goes between all three, right? And the one I want is that black one, the black curve, the one that's going throughout. So that blinky thing, we're going to press enter on that. And then when it says guess, we're going to guess where the blue and the black intersect, or the top curve and the line intersect. So I'm going to put it right on top. And when I do, I'll get an intersecting point of 4, 3. Okay? So we'll stop there. Now, to get the other one, we'll go to second trace again. Go to intersect. This time, we're going to go to the red one, because we're going to go down yonder, right down here. So as long as I'm on the red one or the bottom one, I'm fine. The next one is I want to make sure I'm on that line. So the second curve is the black one. So I'll press enter there. And then the guess, I have to kind of go over here. The guess, just want to make sure it's close. It doesn't have to be perfect. And so it's finding the intersection of the black line and the red, which is -3, -4 at that intersecting. So there's 2, right? 4, 3, and -3, -4. So that's very important when you talk about like intersecting points where they intersect. Is very, very important going forward, okay? All right. All right, hopefully this is helpful for you. I'm going to do the last one. Make sure, let me see. Did I get that last one on there? I think I did. Don't think it's 15, is it? It's, let's see here. All right, let's do this one. I think this one's it right here. Perfect. Okay, so I think it's this one. If not, let me know on that, but I think it's here. It says use a matrices. I'm not going to do that because I think I'm just going to show you how to do it the other way. The matrices by hand can be a pain in the neck, and we haven't taught that yet, so I don't want to go into that. So here's the key, okay? The key to this, and let me get the screen up because it's hard to see without the screen. Let's do that. Let's do that. Okay, perfect. Okay, so like for instance on, we'll call this equation 1, 2, and 3, okay? So what we're trying to do is we're trying to get 3 equations into 2 with 2 variables. If we can do that, then we got it, okay, we won. Now, I see one that we could do. Elimination would be kind of one of the easier methods here. Another method that you could do, actually, as I look at this, I might teach this a different way. I'm going to teach this a different way. All right. Okay, so hang tight with me. What I'm going to do is on this first one, I'm going to look at equation 1, and I'm going to say, what can I get by itself? So I could do x, y, or z. Doesn't matter which one because they're all by themselves. So I'm going to get x by itself. So I'm going to do this. I'm going to say x equals, and I'm going to get negative y and z over. So it should be x equals negative y minus z plus 6. Now, what I taught earlier was correct, okay? It's correct. However, this is just going to be easier, and I'll show you why. I'm going to then take x equals right here, and I'm going to substitute this in for equation 2 and in for equation 3. So in equation 2, what I have now is negative y minus z plus 6. That's what I substituted in for x. Plus 4y minus z equals 2. Now for equation 3, we plug in 3 times negative y minus z. Remember, we're distributing. That's the one thing, don't forget. Minus 2y plus 2z equals 3. Now in blue, use the blue here. I'm going to distribute this 3, and we're just going to simplify. So we have negative 3y minus 3z plus 18 minus 2y plus 2z equals 3. So let's put all the x's or the y's and z's together. So the y's would be negative 5y minus z. And since this 18's over here, let's subtract 18 to each side, okay? So this is going to be equal to negative 15. Okay, so this is equation 3 revamped. Up here, there's nothing to distribute, so we'll just combine the y's together to get 3y. Negative z minus z is negative 2z. And positive 6 equals 2. So let's subtract 6 on both sides. So we should have, for equation 2, 3y minus 2z equals negative 4. Okay? So that's equation 2. And equation 3 is negative 5y minus z equals negative 15. Now, in this situation, since we have now two equations, equation 2 and equation 3, we can then simplify these two by doing what we've normally done. So like we could use elimination. So if I could multiply the bottom by negative 2, we can use elimination on the z. So if I multiply by negative 2 across on here, you get 10y plus 2z equals 30. Okay, so that's no longer there. I combine these two together to get the z's gone like a freight train, gone like yesterday. And then I'm given with 13y equals 26. Divide by 13, divide by 13. Y would then be equal to 2. Okay? Now, since y is 2, it makes it a little bit easier to then plug in. Okay, so we're going to plug in for z here. So we're going to plug 2 in. So negative 5 times 2, right? Minus z equals negative 15. So this is negative 10 minus z equals negative 15. Add 10, add 10. Negative z equals negative 5, which z would then be equal to 5. Okay. Again, it's a long process. Never said it would be easy, but this is going to be a lot better than what we did earlier. Okay, I think here. Then I know that x equals all of this mess, so we could just say x is equal to negative y, so negative 2, minus z, so minus 5. Because 5 I plug in for z, plus 6. So this is negative 7 plus 6, which is negative 1. X is equal to negative 1. So you could plug it in like this. You could just say negative 1, comma, 2, comma, 5, comma, and that's how I get my solution set. I think that's going to be a lot easier than trying to do it the other way by eliminating. Elimination would work. So you could do like eliminate the z's in equations 1 and 2, and then you could eliminate the z's in equations 2 and 3, and get basically, you get the same answers, just a little bit different process there. Okay. Same holds true. Look at number 15. I just noticed that. I could isolate z here, so like get z to the other side, so z equals 2x minus 4. And then wherever I see z, just put 2x minus 4 in for both of the first and the last. And what that would do then is then get two equations with two variables and rock and roll. Okay, so the key in any one of these threes is to get to where we have go from 3 equations and 3 variables to 2 equations, or to 2 equations and 2 variables. That's the key there. Okay, awesome. As I keep going here, do y'all have any other questions for me? I'm trying to see. Let's just kind of take a gander here. One that you might want to look at, one like number 13 that I would do in a situation like that. Well, number 14. 14 is pretty simple in the sense that I can isolate y by dividing by 5, right? The only tough part is that if y equals negative 9/5, just plugging that in for y might be a little tough, and just in getting what x is. Okay, so that might be a little tougher. If I see fractions or decimals here, one thing I can do, if I see it's like over 4 and it's consistent, if I multiply each of these by 4 here, right, the 4s would cancel, leaving me with x plus y equals 28. And all I did was revamp that second equation to where it doesn't have a fraction. Same holds true with the 5 and the 2. If I multiplied all 3 of these, let's say I multiplied the first, second, and third by a common number to get rid of it, I could multiply by 10 here, 10 here, and 10 here, right? So like 5 goes into 10 twice, so I'd be 2 times 2, so it'd be 4x. 2 goes into 10 5 times, so minus 5y equals 40. And then I could use these two equations to either eliminate or substitute either one would work to be able to go forward on that. Up here, since this one, the second one's good because it doesn't have a decimal. Same holds true here. I could multiply each of these by 10 or move the decimal over. If I multiplied this by 10, this would then be 35x minus 23y equals 1, right? Because I just kind of multiplied it by 10 to simplify there. Kind of go forward. All right. Awesome. 11's pretty basic. Kind of use elimination or substitution on that. Either one of those would work. This one right here might be a good one too. Since you have an x squared here, you could get rid of those x squareds by multiplying the top by -3. That would cancel those out. A lot of these systems of equations would be good ones that, again, feel free to use substitution or elimination. Any of those would work. So yeah, did a lot of those. The ones that are here, like 6, now 7, with supply and demand, if you set supply equal to your demand, like set them equal to each other, the point of equilibrium is where they intersect. So that's pretty simple, like where the x and y is. X is the number of units, P is the price of it that you could set it equal to. That's how we use, like, how do we know how much Starbucks can charge? They have a supply and you have a demand. So the supply and demand, where they intersect, we call it the point of equilibrium. And that's the amount of units per price that you normally set those items equal to there. As far as 6 goes and other problems like that, we're going to hit on those a little bit later. In fact, I'll pull up probably some other equations or other word problems that we talked over in class, just to make sure that we're all clear on those going forward. All right. All right. I didn't get any other questions there, which is perfect. About a 35-minute podcast there. Good, solid podcast. Hope you all know, man, I really care about y'all. Anything I can do to help you, please let me know. Tomorrow in class, we'll look at some more questions that you have over any of the problems on the review, or from the problems that we did earlier today as well. Other than that, I hope you have a fantastic day and tear it up. Let's finish off strong this first semester, and then we can enjoy some Christmas break. See y'all. Bye.